Exactly. Well, okay. Well, I think we can get started. So I'll have Abdullah start us off, but just want to let you know that we have Abdullah and Mohammed online coming in virtually, and we're going to have two like kind of halves to this session. But let me give the floor to Abdullah to start it all off.
Thank you so much. So yeah, welcome everyone. And really, Mohammed and I wanted to be at IC2S2 in person this year, but unfortunately, both of us weren't able to make it. And I'm glad that we figured out a way for us to take part, at least in this tutorial. And of course, rest assured that you are in a good hands with Zev Epstein and Matt Groh, who really took the lead in putting this session together. It is unfortunate that I can't see your faces. So again, like Matt and Zev, please kind of, if anyone has any questions, sometimes it's also hard to hear, feel free to kind of wave your hand and interrupt me, and we can kind of take any questions. So basically, this tutorial is about building lab experiments, which is a topic with a long history. Psychologists have been running lab experiments since the late 1800s. Social scientists have started running social interaction experiments at least since the 1960s. And we learned a great deal from those experiments because they provide high degree of control over the environment. So they are really optimized for identifying causes and effects and linking them together, especially when testing specific theories. And so these pictures that you see on the screen, I pulled them from a paper published in ASQ on how to set up a physical lab to study social interactions. And I think they did a pretty good job, because if you look at today's physical lab, they don't look very different from those from the 1960s, at least in how they are kind of set up and how they operate. But also they inherit many of the same limitations that people have pointed out about lab experiments over the years, things that include the problem of representative samples, where typically participants are homogeneous university undergraduate students. Most interactions are really short-lived because there are so many hours that you could trap undergraduate students in a room before the IRB office or officers come and stop it. The physical constraints also mean that interactions are limited to very small group sizes. And because of the very high overhead in administering those experiments, the sample sizes tend to be relatively small, to be well powered, which means that there is a higher chance of producing false and non-replicable results. And as a consequence of that, the tasks are typically distilled down to the very bare minimum. So they are artificial and stylized in order to reduce noise in the data, which probably also reduces the external validity of the results and their value to practitioners. And not also to forget that they are quite expensive to set up, they are difficult to operate, they are hard to replicate, and they are just like have this kind of inherent limitations to them. So if you think of all of these kind of criticisms and try to roughly collapse them into 3 dimensions of like scale or size, complexity or the richness of the experiments, and duration, then you can define this somewhat abstract conceptual design space of possible kinds of lab experiments, right, across these defined by these dimensions, where probably the physical labs lay in somewhere around the origin of that space. So basically, the constraints, these physical constraints, limit the kinds of lab experiments that one can design and run to somewhere near the origin here. And it immediately becomes clear that the idea of virtual labs, which is basically running experiments online on the web, is appealing on the ground that it can lift many of these historical constraints. Right? So for example, by relaxing the constraint of space, you don't need to put people in the same room anymore. Now we can have larger groups with large scale interactions. We can have larger sample sizes because we have access to more participants, and we can have more variations of the experiment that we are running to increase its robustness and generalizability. Also, it enables the participants to engage with the experiment for a very long period of time, given that they don't have to be trapped in a room for the entire duration of the task. And you can create more immersive environments that are representative of the digital environments that people are used to and typically interact with and engage with outside of the lab, which should increase its ecological or external validity. So with this kind of expanded design space enabled by going online, we would expect to see new experimental paradigms that are qualitatively different than what we already see in the physical lab. So we don't expect people just to run more of the same, but with this kind of new possibilities, new ways of asking questions and about social science and answering them might emerge. And definitely there has been a lot of exciting progress that has happened in the past century and a half, almost like more than 60 years ago now. A lot of this work has been done and pioneered by people who are probably at IC2S2 right now or involved with the conference in some capacity. So I would encourage you to go and talk to them. However, the reality of virtual labs is that most of our experiments mostly resemble physical lab experiments, just a little bit cheaper and somewhat faster. So we still can't really, or it's not commonplace to do experiments that study emergent behaviors in the lab of very large interacting groups. So studying entire communities or an army in the lab, it's still not really possible. And there are very few examples of that. We still can't really run network experiments with thousands of people interacting with each other per network. We still can't run hundreds or even thousands of variants of an experimental paradigm to examine the robustness of a finding or to examine the generalizability of results. So although there is a lot of progress and we've been kind of really expanding the design space beyond getting further away from the origin, it's not the way that many people have envisioned. And of course, there are many challenges that are preventing us from taking the full advantage of this kind of online experimentation paradigm and this expanded design space to truly increase the throughput of experimental social science and what we can do with it. This is a topic of a prospective piece that we've been working on for a couple of years now and currently under review. And I'll be more than happy to share a draft with anyone who's interested, but also Tom Griffiths, who is one of the keynote speakers at IC2S2, I believe he's going to give his talk on Thursday, is going to talk more in details about kind of the meta-scientific view of running experiments online and how to think about some of these challenges and addressing them. But the challenge that we really want to focus on today, and it's the topic of this tutorial, is the substantial programming experience required in order to really innovate and implement and scale up and really benefit from this expanded design space when designing behavioral lab experiments. So luckily, there are several tools out there that try to address this challenge in various ways. And today we'll hear about 3 of these tools that we are involved with: Empirica, Thorat, and Yourfeed. And this will be followed. So each of these tools, you'll hear a little bit about them from Mohammed, Matt, and Zir. And then this will be followed by a Q&A short session where we can discuss these tools or virtual lab experiments more generally. And finally, we'll have a breakout for the hands-on portion of this tutorial where you'll get to actually implement an experiment using some of these tools. So with that, we'll start with Mohammed, who will talk to us a little bit about Empirica.
Thanks, Abdullah. Let me just share my screen. All right, are we looking good?
Perfect.
Cool. So I'm excited to be sharing Empirica with you all today, and thank you so much for joining us in this tutorial. My name's Mohammed. I'll be sharing kind of the philosophy and design of Empirica with you, and hopefully that gets you on board to try it for your next experiment. So just starting from the title, Empirica is a virtual lab, as Abdullah explained. So it's an online environment for interactive experiments. for high throughput macro level experiments. So high throughput, we think about frequency, we think about ease of deployment across a wide range of conditions. And macro level, in addition to thinking about the micro individual level, we can also use platforms like Empirica to study the behavior of collectives. So starting from a dyad to a tribe, and so on and so forth. So that's what Empirica is, and why you should use Empirica. I think there are kind of three main points to think about. The first is what Empirica enables you to do and how it empowers your work. The second is how Empirica encourages researchers to think. And the third is the community that we've been very happy to see grow around the platform. So what we mean by low fuss productivity is if we think about platforms that exist for virtual labs, we can compare them along two main axes, ease of use and flexibility. So on the top left quadrant, so anyone can use Qualtrics, but the applicability is fairly narrow. And there are tools that extend the usability, but that's generally the case when it comes to platforms like survey builders. On the opposite side of the spectrum, you have a full-time software engineer. So they're very specialized, but they can do anything. And there's a smattering of platforms in between. And where we've endeavored to kind of place Empirica is somewhere in the top right quadrant. So from experience, we've seen that junior undergraduate students with a little bit of experience in JavaScript can create a full real experiment in days. And so the way that we like to think about it is if you can think about your game and about your interaction and implement it as a JavaScript game, then Empirica takes care of the rest when it comes to lobby building, randomization, recruitment, etc. In terms of how Empirica encourages researchers to think about their experiments, we try to think about the design of experiments as composed of factors. So factors are the building blocks which you add together to create experimental treatments. And the philosophy here is that the outcome of an experiment depends on the context. And we encourage researchers to think explicitly about what they would like to vary based on their research questions. So it's about thinking about the factors themselves, the way that they interact with each other when you're defining a new treatment as shown on the left, but also to think about the things that you've implicitly chosen to ignore. So when you're implementing something in JavaScript, you'll notice, oh, this was hard-coded, this could be a factor, and that gets you to think about the contingency of results on the experimental conditions. The third kind of selling point here is the amazing community that's coalesced around the platform. So I like to think that the best use cases are the ones that are yet to have been developed. And through the Slack channel of over 180 members, we've seen people contribute new functionality to the core Empirica platform on the open source GitHub, but also come up with new and interesting ways to design experiments on Empirica. And all of that has led to the community being highly productive. So since 2020, the community has run 50+ novel experiments. So these are designs that we like to think are uniquely empowered by Empirica's design. And this has been done across a wide range of teams and institutions. But that's all fine and dandy, right? I think some of us might have had experiences where we love a platform, we start building on top of it, and it crumbles like a house of cards. And that's why sustainability and reliability has been at the forefront of kind of Empirica's development strategy. And so through the very generous support of SAGE, the Stone Foundation, and the CSS Lab at Penn, Empirica is built on a team of core developers and has a roadmap for sustainability and reliability. So we want to make sure that new functionality is enabling new modes of inquiry, but also the things that already exist continue working as your own research develops. Now, the rest of the tutorials today will have breakout rooms. So you'll learn about Yourfeed and Thorat later on in the tutorial. For Empirica, I encourage you to follow the self-guided tutorial at the documentation page shown here. And if you take a picture of the slide, the QR code will lead you to join the Empirica Slack, where we can support you on the IC2S2 channel if you run into any issues with the tutorial. And thank you.
All right, so talking about that spectrum Mohammed was just talking about, there's easy use and flexibility. And we kind of want to make it as easy to use and as flexible as possible. So what I'm going to talk about is Flask Thorat, which is essentially a scaffold for building dynamic websites. And so to start us off about what this is, I'm going to talk about the traditional no-code virtual labs that you see today. So it starts, as Mohammed was showing, in the easy use kind of, but not that flexible category is this Qualtrics survey, which then maybe we get people coming in from Prolific or MTurk, and we get some kind of CSV at the end of the day, and kind of nice to work with if we're not going to build tools like dynamic websites ourselves. But there's a problem, too few stimuli. Of course, you can scale up the number of participants, but often there's not that many images or videos or whatever kind of media you're working with. And one study from 6 years ago showed that basically actually 65% of media studies papers have only a single stimulus in the studies. And so there's kind of some generalizability concerns there. So we want to address those. The other thing is you scale with dollars, which is nice because you can scale up, but also for grad students and people who maybe have less of a budget, it's kind of difficult. And there's other ways to do that. So I'm going to talk about those. And the other thing is it's difficult and sometimes even impossible to customize the things you want to do. And so maybe you want to have thousands of stimuli. And there's examples that I'll share. Maybe you want to have timestamp on all the clicks that you're doing. Maybe you want to have logic or designs to prevent people from doing one action until they do some other kind of action. And there you're making sure that they're paying attention to your experiment. Maybe you want it to be more interactive. So an example of a custom virtual experiment built with this Flask Thorat framework is something we call detect fakes. And it's an experiment where we ask a simple question on the top. Did Donald Trump say that? We show videos, and then you say how likely you think it's real or fabricated. You submit, then it will tell you the answer, and you just see a bunch of different images. And so the idea is that it's the same kind of framework, but you're seeing a bunch of different kind of media. And it could be videos, but it could just be a little HTML text snippets. It could just be audio. There's lots of different ways you can plug stuff in. And then to kind of build these things, all you're doing is dragging the media files into a folder. And then you're just randomizing, for example, what kind of thing you might want. You have sliders that you can play around with. And what we've tried to do is set this up so you can play around with these component parts and maybe change it to be something like this. Another project we worked on around this, which is called Diagnosing Diagnosis, where we're asking medical professionals like dermatologists in general, PCPs, primary care physicians, to try to diagnose skin conditions from a single image. And basically here you have stuff like a place to enter your diagnosis, which would have predictive text, and then you can get a sense of how accurate people are, especially in cases where there's lots of different names for the same thing. It's a way to kind of reduce the many different ways people might describe something by. And just to give you one more example is, and I'm gonna move this so we can actually see what this looks like. Oopsies. Oh. Here's just another example. This was a little bit more technical framework where we're using Django instead of Flask and using a couple different kind of front-end frameworks like React. And there's a TypeScript component, but basically what you get is something that looks like Wordle. And then we're able to throw something else into it. And so there we have a virtual agent giving you some feedback, trying to motivate you to do better on a kind of task. And so the idea here is that what we're trying to do is build the tools to scaffold people to do whatever they want, rather than kind of stay in the narrow lane of a single kind of questionnaire. And so in the tutorial version of this in the next 45 minutes. What I'm going to walk through is how to set up your own local web server, how to create URL endpoints. It's okay if you don't even know these terms, you'll know them at the end of the 45 minutes. Injecting code into HTML templates. We're going to abstract away a lot of the HTML, CSS, and JavaScript because we actually don't need to know that for a lot of the experiment building. And then we're going to show what a standard survey looks like, how to design these custom multimedia experiments, save data in a SQL database, which at the end of the day will mean a couple of different CSVs instead of a single CSV, but we'll show how to do that and then how to query that. And so there's a link to where that tutorial is going to be, and we'll get started on that link after Zibby's presentation. And really all you'll need to know for this is a very basic understanding of Python. So that's the Flask Thorat tutorial kind of overview, preview.
Great. So the next one to kind of wrap up this first part of this is talking about a platform called Yourfeed. And as Matt was talking about, a lot of times, at least in my lab, we've been using Qualtrics to kind of run these experiments, and in particular, looking about trying to understand social media and the impact of design on user behavior on social media. So, there's a lot of questions about how newsfeed algorithms or like buttons or all the kind of features we see in social media actually impact the extent to which people engage with or believe certain types of content. So we use Qualtrics historically to kind of answer these questions, but it's kind of very lacking as a platform if you really want to think about ecological and external validity. And in particular, it's really hard to actually think about how you might run experiments on social media. So, there's these kind of barriers, and a big part of that is social media platforms have misaligned incentives to actually share data and kind of talk about these things, and actually might be making things worse through dark patterns where they're trying to optimize algorithms for engagement, try to get you to stay on the platform to click on ads and whatnot, and a lack of transparency where there's a couple people within the company who are kind of making these decisions unilaterally without any input from users. And so it's kind of hard to study this in academia and actually build public knowledge about the impact of these designs on behavior. There's been kind of experiments to do this. So SS1 was a partnership that Facebook, Meta made to kind of bring academics in to kind of give them data. But there it's kind of who do they choose to kind of come in? Usually people whose research kind of aligns with their interests. And also the data that they get is usually aggregated and only a kind of slice of it that kind of works for Facebook's agenda and these companies' agendas. There's kind of field experiments, which Abdullah was talking about a little bit, where you can kind of make a botnet and you wrangle the APIs to try to interact with people in the wild. We've done this as well, but ultimately it's super challenging. The platforms are evolving in real time, so it's not really replicable, and kind of poison the well by making people think that they're not actually engaging with the real platform. They're just interacting with these weird bots. And then the final alternative that I think most of the kind of research on social media has leveraged is Qualtrics, where you basically show someone a screenshot of the headline and be like, if you were to see this on social media, would you share it? And obviously that's not very great. So to try to bridge the gap a little bit, we've developed this tool in collaboration with Houselin called Yourfeed. So it's this ecologically valid social media research tool. And some key features of it. One is it actually has a kind of news feed that you can scroll and browse that kind of mirrors the attentional properties of social media versus Qualtrics, where it's you see one item at a time and then you're kind of forced to pay attention to it, versus when you're kind of browsing, it's a completely different kind of attentional mindset. Second, we actually measure dwell time for every single post. So kind of how long people pay attention to everything is this key metric that all of online advertising is built on. But if you're a researcher, you don't really get access to this dwell time data, and it can be really hard to kind of reason about it. So the idea here is to really kind of surface that for experimenters. It's also a framework for kind of experimenting with newsfeed algorithms. You can actually say, these people will get this newsfeed algorithm and these people will get this newsfeed algorithm, and actually look at the causal effects of assigning people different algorithms and being able to evaluate them in this really kind of ecologically valid way. And finally, it's kind of fully interoperable, which means that there's all these kind of modules and components. Maybe you have a modal or a design intervention. Maybe it's an algorithm. Maybe it's a stimulus set. Whatever you want as a researcher, you can kind of plug it in anywhere along the chain. And I'll kind of show you what that looks like. So first, you basically set up the kind of parameters of your experiment. What are the conditions and what are the properties of each condition? when a user then comes to a particular Yourfeed URL that you've generated, they're basically randomly assigned to one of the conditions that you've specified. From there, there's entity sets. These are kind of corpuses of entities or posts, you might say, that people kind of see in their feed, that you can kind of custom specify which ones you see which participants to see. From there, the entity sets for that user in that condition is fed through a newsfeed algorithm that kind of ranks and sorts it. And again, this is a module where you can just have it be random or actually plug in your own kind of, my, algorithm.py, and it will actually kind of use that on top of this. Then it populates the engagement for this. So this would be this kind of synthetic data or actual real data of people kind of clicking and interacting with stuff. And then finally, you display that to the user in a feed interface with the kind of styling and customization that you want for your experiment. For this tutorial, in the second half, we'll focus on a case study, which is the effects of social cues on engagement. So the idea is you might have two conditions. The first has the number of shares and likes that a post has on the left, and on the right there's no number of likes and comments. So this kind of quantified engagement metrics. And we actually have a full kind of paper on this that I'm talking about on Thursday. So swing through if you're kind of interested to hear more about that. But for the purpose of this, we'll actually step through making that survey on the interface. It's just in a form. You don't need any coding experience whatsoever. And then we'll actually generate the link, share it around, play with it a little bit, and then download the data and interact with that in R. So if you're interested in that, check it out. So that's it. And with that, we will kind of open it up to questions, comments, Q&A. Well, we have Mohammed and Abdullah with us. And then at 10:45, 10:50, or 11:45, 11:50, we'll transition to the Thorat and the Yourfeed tutorial. So thank you. Do we have any questions or thoughts, reflections?
I'm quite interested in finding network experiments, and I think it was mentioned previously that that's possible, but it's quite difficult to keep people engaged for a long term, to keep them retained within the experiment. I'm wondering what are the recommendations in any of these three platforms that you mentioned to do that.
Great. And I'll just repeat the question so Mohammed and Abdullah can hear it. So the question was about network experiments, and particularly how do you get people engaged for the long term, as opposed to just some kind of small time segment. And I think maybe you guys could speak best to this because you guys really focus on networked experiments.
Yes, so one thing that sorry, I think I was hearing some echo. Okay, so one thing that we are doing actually now with some of the experiments that are being implemented on Empirica allow users to come in, make decisions, and then leave the platform, but it's kind of sticky in the sense that we built a virtual world where they can interact with each other. So you can think of it something like a prediction market. And then participants can hop in, they make their predictions, they can kind of bet on things, and then they leave. And then whenever they come back, they can see and observe the decisions that have been made by other people. So by allowing for both synchronous and asynchronous interactions that are sticky. So once you are assigned to a world, you are assigned to a treatment, you are always assigned to the same instance, to the same world, and interacting with the same participants. By allowing for asynchronous interactions, you can envision kind of some ways to allow for long-term interactions. There has been other examples, not necessarily done on Empirica, but there is a paper by Andrew Mao and Duncan Watts on cooperation games, where they had participants play Prisoner's Dilemma for 30 consecutive days. But then for that one, it was a lot of complexity around setting up the incentives, where people actually came in, they did the task for an hour every day for 30 days during work days only for a couple of weeks, and really study the effect of long-term interaction for the sustainability of cooperation. So there are ways, kind of depending on the particular task or question that one have in mind, one can potentially think of different ways, either doing things asynchronously or setting up an incentive to allow people to kind of come in and join the session at the same time over a period of time can potentially allow for these large-scale network experiments that run for a long period of time.
And I think that kind of goes the same thing for like the Thorat kind of setup, where we often have like a crowd wisdom or an AI prediction component to it. And so that will be based off what everyone else has already said at the moment. And so that can be like a, of course, changing kind of direct like component. And I guess the thing there is you have user IDs could be one way to play with it. If you want to have a really light app, you might just use cookies and have, whatever, that particular browser having logged in before. So there's ways to kind of track users and make sure that you're kind of assigning people to keep them in the treatment or control or whatever group.
And if I may follow up
Yeah.
on that, because you just kind of reminded me of another kinds of experiments that are long running that have been implemented on Empirica. And if you check on the website and our success stories, there is a paper by Iyad Rahwan and others that built an experiment to study cultural evolution, where it's a temporal network. So like you build, everyone kind of starts from where the previous participants have left off and kind of coming up with a solution. And also there are, we interviewed them and kind of got published on our on the Empirica website how one would be able to implement those kinds of experiments. So if what you have in mind is kind of these cultural evolution over time kind of experiments, then there are examples to learn from that paradigm too.
So thanks everyone for interesting talks. I have a question for Steve. So regarding the newsfeed algorithms, I was wondering whether this could be interactive with other participants or that just for individual users to.
So you're talking about like a newsfeed algorithm that like is responsive to other, like tell me more. This is interesting.
So I'm thinking about the social component, right?
Mhm.
Social media. So just trying to understand whether we can model or incorporate engagement with like, other actors in the experiments. So this is feasible.
Yeah, it's a super good point. So at least, and I will say that like full disclosure, Yourfeed is like, we are actively developing it. It's kind of this is like literally today, this week is kind of like the public release of it. So super, if there's interesting questions you want, like let's talk more, let's figure out how to kind of build these things in. The current implementation that we have like today, how it works is that when a user lands on the site, they're randomly assigned to a condition. They're like the items, the inventory that they will see, and then you basically pass those inventory of items to the kind of custom Python script that you have to basically figure out the order of those things. And what happens there is that this newsfeed algorithm, the Python script that you provide, it can take any form that it wants. It's a black box, but the inputs necessarily have to take a data frame of the items, the inventory that are being received to it, and just a connection to like the database of engagement, as well as references to the participants' information, like covariates of some sorts. And then the output has to be just a data frame of the same exact inventory but in a different order. So the idea is that in that kind of black box, it's kind of completely up to you to kind of tailor what kind of thing you want. And so the basic thing we did, is you could say, okay, you could randomize it, send it in a different order and ship it. Or you could say, okay, based on, some existing, features of the content, maybe order them in that way. But then what you can do is do this kind of dynamic stuff where you say, okay, for each item, let's pull in, how many other people have shared this item in this Yourfeed session, merge that data in, and then sort by that and return that kind of thing. So I would say that like the way we've kind of architected it allows for this kind of black box newsfeed algorithm that you can kind of provide full. No one's done this yet. So this is theoretical here, but the idea is you can really kind of specify and choose the kind of algorithm that it kind of fits your research question.
I guess overall, what is the accessibility for people using this? Like usability and like, is it easy for anyone to use? I know there was the in the past, but what are some like easy entry points for us to kind of help our other researchers go along?
You want to start that off? 'Cause I
Sure.
think yours has some-
Yeah. So we'll talk about it a little bit in the session, but basically we designed Yourfeed to be completely except for the algorithms that you provide, but just be really like it's a form. It's like, here's your conditions, which of the conditions, like all the stimuli you want. So the idea is you can actually build a whole interactive randomized thing without any programming experience whatsoever. And so, I think, and in many ways, Qualtrics was this promise to try to have like a drag and drop interface for building experiments. But ultimately, it's kind of the worst of both worlds, where it's like actually ends up being quite complicated and not as flexible as programming a little bit. So I think that there are opportunities to make tools that are, very easy for people to interact with, that you don't require any programming. But then also, like, as I think Matt will demonstrate, with just a little bit of Python knowledge, you can build these really kind of complex and interesting and sophisticated tools. So I don't know.
Yeah, and I'd say each of these three tools are on a different spot on that spectrum between easy use and flexibility. And for the Flask Thorat tutorial, the whole point is to give a starter pack to people who aren't used to building dynamic websites to be able to do it where they don't have to understand how CSS works. They don't have to understand how JavaScript works. There's opinions built in for the kind of things that we think computational social scientists will want to ask in digital experiments. And of course, you can do anything, but we've tried to structure it so there's a bunch of things that kind of maybe first level, second level kind of experiments can be done quickly. And I think in 45 minutes, you'll see that you can get this thing up and running. It actually looks good. And I think maybe I'll let you guys talk about that easy use trade-off with flexibility for Empirica.
Yeah, so the ease of use flexibility trade-off is a hard one to break out from, right? It's kind of a real decision that the platform designer have to think about. So with every decision that we are thinking about, we say that, okay, if we add this additional feature that makes our current use cases easier to implement, how does that prevent future use cases that we couldn't even think about right now, right? And there is really a trade-off there that we are always thinking about. So within the Empirica, we try to take a lot of the functionality that are common across all experiments, what makes something an experiment, out of the way. So things like randomization and how do you actually assign people to conditions? How do you define conditions? What are treatments? What are participants? What is a batch of conditions? We take all of the things that are common across many experiments, we abstract them, and you don't need to do any programming to customize them. So you can create any waiting lobby or any way of assigning participants to conditions, and it's just a drop-down menu that you select from. But simultaneously, there are parts that actually require some programming. They require programming because we want you to be able to implement any logic or any experiment that you think is ideal for your question to be possible to be implemented. And we provide an API that simplifies that process. So it simplifies things like synchronization across participants, saving data in the database, making sure that if failures happen, then they are handled gracefully. And by providing these APIs, we kind of lower the barrier to entry. However, it does require some programming. We've run a bunch of workshops where we had people that come from all kinds of backgrounds, from psychology, humanities to computer scientists. And we actually observed them go through the tutorials and look at where failures can happen. And we are always thinking about how to simplify these kinds of failure points in order to help as many people to be able to use the platform. However, there is a learning curve that a person have kind of to go over in order to be able to use something like Empirica.
Maybe the learning curve is, oh, sorry, I was just gonna say, maybe the learning curve is like a learning opportunity too, where it's kind of scaffolded in a way that you're gonna get to something good. And we try to kind of spoon feed growth on that development front.
Yeah. And I might add to what Abdullah said, that the Empirica API, I think, is interesting because it intuitively maps like experimental conditions to the implementation of the game. So the way that React passes the parameters and the way that you invoke them when you're designing your JavaScript interaction or your game, it's clear to see how your design decisions at a high level are mapping to the actual implementation. And I think for people who are in a bit of a rush or would rather kind of outsource the JavaScript and the coding side of things, this is also like a pattern we've seen where people work with outside developers. And we've actually tried to collect this list of collaborators and implementation partners into what we call the Empirica Developer Network. So for researchers who would kind of like to bring on a partner who's a bit more coding savvy for that, that's part of the community that we're trying to flesh out.
One last thing just to add on this is that like, and I just kind of piggyback on what Mohammed was saying, is like, I think for all of these computational tools, like anything, it's like really building a community and like people around you who are like doing similar stuff that you can like, you get stuck, like you can ask them a question or like brainstorm, all these kind of things. So whatever, you know, whether it's these three or anything else, it's really trying to figure out, you know, like who are the other people doing similar stuff and how can you kind of build these networks where you can have chats and try to figure out what it is. So like the fact that, you know, Empirica has this like Slack with over 180 people who are all like, you know, oh, like, how does this work? Let's try this, you know, or all these kind of things. Building communities around this, I think is the best way to kind of get unstuck and like level up your skills.
Maybe we have time for one more question.
Yeah.
And then one more. Well, maybe people are excited to just get started.
Yeah. Great. So, okay, with that, we're going to like transition to the second half of the tutorial where I hope you've been like thinking